machine learning models, they don't take decisions. Models, they make predictions, and then it's up to you to actually use those predictions to make those decisions that make sense for you.
Welcome everybody to the Surf AI Innovators podcast, a podcast where we look at how artificial intelligence and machine learning can help and benefit education and research. And we are now at episode 7 already. And in this episode, we have Giulio Soto from Amazon AWS. Giulio is the head of the Machine Learning and AI Solutions Lab for Europe. That sounds very, very interesting. Hello, everybody. Hello, Duke.
Hey, Andres. Good to be here again.
Great to see you and hear you. Hi, Thomas.
Hey, Andres.
So the hosts from Surf are here. The AI Innovators team is here and ready. And Giulio is here as well. Hi, Giulio.
Hi, everybody. How are you? Thanks for having me here.
Giulio, thanks. We really appreciate you taking the time to have this conversation with us, and we have a lot of questions for you. The first one we were thinking about is, how on earth did you end up in this AI ML domain? It wasn't something that when we were young you could say, "Oh, I'm going to be an AI specialist," right?
Oh, definitely not. And it's kind of funny because actually I don't have a machine learning or AI background. I am an old-fashioned engineer in telecommunication, and it kind of started very interesting my path in machine learning because I was a solution architect for Amazon Web Services working in the public sector, so helping universities or government to start understanding how cloud computing could really make a dent and could really help for their processes and businesses. But at a certain point, it was 2014, 2015, Amazon came up with this fantastic thing called Amazon Alexa and Amazon Echo. And I am a very geek fan of Star Trek. And so the first time that I actually, saw the Echo device and I started talking with Alexa, immediately it reminded me of the computer of Star Trek. I can remember Picard asking computer, where are the Klingons, or Red Alert. And so, I started to try to understand how it worked. But, the passion about the layers behind Alexa brought me to actually apply to an Alexa position in Amazon as an internal. So from Amazon Web Services solution architecture, I moved to Amazon Alexa, leading the technical teams here in Europe. And to be honest, one of the most compelling reasons for me to actually join the Alexa team was because I really wanted to understand how it worked. And so that was when I actually started to understanding things like natural language processing and natural language understanding. So I really become passionate about the topic. And at a certain point, we in Amazon Web Services decided that we really wanted to kind of share the experience we had, doing machine learning, 20 years in Amazon with other customers. And so we embarked into this new team called Machine Learning Solutions Lab, which has exactly the goal to help customers, accelerate the adoption of machine learning. And so I joined back AWS for leading this team. And that was amazing again, because, I had another excuse to actually go deeper and not only move to from NLP and natural language understanding, but actually going deeper in computer vision and other topics. So that's basically how it started from Star Trek, I would say.
Nice, Giulio. And about that lab thingy now, is that like really a lab with a lot of devices floating around and you walking around in a lab coat and talking to all these Alexa devices?
We don't yet have the Doctor Who, phone booth, but The lab is really hands-on. So we what we do is pairing with the customer's development team, data scientists, and co-developing with them models that really can bring value to the business, and sometimes even pushing the envelope of what you can do with AI and machine learning. So that's a fantastic journey because you can see how machine learning is actually real now. It's something that it's not only on the academic side. A few years ago, it was a very interesting topic to study, but right now we are seeing the application everywhere, and that's amazing because you can see it from autonomous cars till the phone that we have every day with us. So that's a very interesting field.
I like the analogy that you have with Star Trek. I have a similar thing with, you might know that TV series Knight Rider, where Michael Knight was always talking to his car, and he had this watch that he could talk to his car. Man, who would have thought when we were little, right? That one day we could talk to our watch as well. And then you can talk to devices like this. It's amazing.
Yeah, you can actually talk with your car now, right? And pretty soon, actually, they can drive our basically everybody of us, like Kit did in the series.
Yeah, exactly. So I'm just wondering, because the whole Star Trek talking to the computer as an inspiration to get into this talking assistant thing it makes me think of a friend of mine during my studies who basically had the same story arc almost. How many of your colleagues have the same ambitions now, coming from the fact that they watched Star Trek when they were younger? Oh, that's a dangerous dangerous comparison.
Don't compare them.
Well, I'm also a Star Wars fan, so that's good. And we have androids there as well, so I think it makes sense. But I think that this is something very, very important, is that, again, I was saying, Amazon does machine learning 20 years, for more than 20 years now, from supply chain optimization to a recommendation system. But I really think that the key for making machine learning more accessible is to actually make it easier. One thing is requiring data scientists or practitioner to actually do machine learning. Another thing is actually having every developer being able to create smart application with machine learning. That's exactly what is happening in the market, I think. So what we are trying to do is, I would call it democratizing AI and machine learning, making very easy for everyone that has traditional computer skill development, being able to create those smart applications themselves. That's basically what we did, and so I am sure that there are plenty of Star Trek fans everywhere in the tech industry. And now we're giving all of them the ability actually to create models and create interesting application with that.
Yeah, great. I think it's certainly interesting, and we'd love to hear more about the modeling work and how you and your colleagues try and make this accessible. It's always striking to us that we think AI and ML are already around us, right? It has already an impact on people's lives. Is that also that you see that it's already here today? And do you perhaps have some examples of how machine learning already impacts people's daily lives?
Oh, absolutely. I think that a lot of applications of machine learning, they are here, and we probably don't even know that they are here among us. So, for example, every time we swipe our credit card, most likely there is a machine learning algorithm that is figuring out if it's a legitimate transaction and fraud detection, basically identifying if is really you or somebody that stole your credit card number. This one is an application that we of machine learning that we actually see every day, but you probably don't realize that is behind. Or we are watching video streaming and we are watching shows, and there is a recommender system maybe that is suggesting us what to watch next. Again, this one is an application of machine learning. Or many of us, especially some of us that live in countries that are multilingual, we train ourselves and we try to learn new languages. And there are applications such as Duolingo that use machine learning to suggest exercises that you might want to do. So there are a number of applications of machine learning that we actually use today, even in our phone. But still, I think we are entering the golden age. So I'm fairly optimistic that this is just the beginning of our journey, using AI ML. We are seeing a lot of things already, but more to come, I guess.
You mentioned something interesting around learning languages. I think we all come from a generation where at school you had to learn a lot of languages. Is that still necessary, or can I just get my translator out and speak Italian to you?
Well, definitely there are services that helps you in that direction. I mentioned Duolingo as an example, but sometimes is very useful even in traditional learning situation. For example, let's say that you have an interesting video that you want to watch. Previous generation, we had translators, translating every single video in a different language. Now you can use services like, Amazon Translate is one of them, where you can transcribe first your audio and then have translation on top of it. I think it's interesting because opens so many possibilities. I think again it makes more accessible the content. Which is another advantage of those services.
And I'm just wondering, like, if we take conversation, of course, all us here have learned a second language, which is the language you are talking in right now, which is always a bit different, right, than your own language to pronounce, to make your point and to be detailed. If we talk about these models translating languages, do you think at some point they will be able to be a serious competition for learning another language in the way of understanding these nuances, like the fact that another language might make you think in another way as well?
I don't think it's going to be a competition. Again, it's a tool. I think it's going to help us, understanding maybe dialects, maybe different meaning that we give to words in different languages. Again, talking about dialects, you can, you of course can tell that I'm Italian right from my accent, and I'm surprised how, for example, Alexa can really recognize my English. So I think we're getting there. Again, is a long way. We are in the early journey. But definitely, I believe that quickly enough we can reach a point where we can freely talk and using other interfaces to communicate with technology, which I actually think is one of the most interesting aspects of AI ML. So another thing that is actually doing is removing barriers to interact with technology. So, for example, we were talking about voice and how we can now finally interact with machines with voices. But another next step can be, in interacting with gestures or location. Actually, I'm close to my home, so everything can be connected through AI and understanding. Okay, it's this time of the night. This is probably what I want to do.
So I think that's a super interesting distinction there, because I do agree, like it's completely changing the way we're interacting with technologies, also the way we're interacting with our surroundings, because our surroundings are getting more and more having embedded systems in them, so that barrier between the physical and the digital domain is blurring, every day getting more and more blurred. For me, it seems like there's still a difference if we talk about interaction between when I, for example, would I set my lights at home each morning to wake me up, right? So they slowly get brighter. That wakes me up. It's a setting that I have set because I want to wake up at that time. And at some point, you can also get this, like you suggest, Julio, that based on your location, the system knows what you might want to be doing. At what point does it change from interaction to, I want to say influence, it's not completely the right word, but where you're no longer consciously interacting with the system, but the system is shaping your surroundings, even perhaps with your knowledge or vaguely with your knowledge?
Mm-hmm. Yeah, it's an interesting question. So one thing that I always tell my customers is machine learning models, they don't take decisions. Models, they make predictions, and then it's up to you to actually use those predictions to make those decisions that make sense for you. So like every technology, we need to use it as a tool for helping whatever we are doing. So basically, you want to use the technology in the way that is most useful to you and supporting your life. So
that makes sense.
Talking about the word predictions, that's a difficult question perhaps, but do you have a vision on where this will be heading in the next 5 years? Well, where will we be in 2025?
Yeah, we're talking about prediction. You're asking me to make a prediction,
yes,
right?
Don't ask Alexa now, please.
So I think, as I was saying, we are just entering the journey. And I think that probably in 5 years, we are not going to talk that much about machine learning and AI because it would be so ubiquitous. It would be probably so common to have applications that have some flavor of AI, ML, that it would be like, talking right now about mobile application having icons and having a touch interface. It would be natural. So that's where I actually see that we are going. And again, this is something that you can do only if machine learning and AI isn't something that is only in the domain of scientists and people that actually have knowledge of the inner machine learning algorithm. So it's something that you can only reach if you make the ability to create application using AI/ML available to everybody that has some IT skills.
That still sounds sorry. That still sounds for me abstract. That everyone will have access to creating AI-driven applications. Maybe you have an example of such an application where people took AI and made a product or made something which actually surprised you, that, or maybe to frame it a bit different, people took AI and made something where it was not expected. Do you have any examples?
Yes, I have few. So when I say that we need to make AI more accessible, the way we are doing, for example, in AWS is to provide options to developers and scientists in the sense that depending on what is the level of your skill or your skills in general, you can choose, for example, to go in the deepest layer. So you have access to the frameworks such as TensorFlow, of PyTorch, and the deep learning virtual machines that you want to use for making your models. On the other end of the spectrum, if you don't really want, or maybe you don't have data to train your models, because machine learning usually needs a lot of data to get meaningful results, you can use API services basically with just a quick call. To one of our services, for example, recognition, which is for computer vision. You have, as a result, labels that tells you, okay, what I see in this picture is a cat, or is a dog, or is a car. So there is one example which is interesting. So there is an Amazon employee which is not, I would say probably, which was not a developer, but a program manager. And he had a very serious issue. He has a cat, and he's an outdoor cat. So you probably know, if you have cats that goes outdoors, that they have a singular habit. They just go and hunt, little animals in the garden. And so usually what they do is they bring you this present at home. And so basically his colleague, he didn't really want to have those, corpses of little rodents laying around in the house. And with no machine learning skills, what he did basically was using a device that we have, which is exactly for educational purpose, which is called Amazon Deep Lenses, and created through Amazon SageMaker, which is a platform that helps you to create models, and we're using computer vision algorithms or any other types of machine learning algorithms. And he created this application all by himself. Again, he was not a machine learning data scientist, that could identify when the cat was coming close to the door with something in his mouth. And if he had something in his mouth, it basically blocked the door. So the cat couldn't enter until it dropped the prey. So this is a nice example of somebody that doesn't have initially machine learning skills can still make meaningful application. And I think it's fun because it's an everyday problem that has been solved, by again somebody that didn't have those skills before.
I would like to get that code, please, because I have the same issue with my with my cat. I'm still waiting on the next level to try and prevent my cat from hunting and bringing me those presence, so to speak. I think it's a very nice description also where we are at the moment, and how we look at what companies like AWS and others are doing. On the one hand, we see these tools being used by high-end research for very specialized tools where the real experts have the abilities to create their own models and processing, etc. And on the other hand, the democratizing part that you already mentioned, Giulio, in getting it in the hands of mere mortals, so to speak, and having it towards a broader user base. That's something that we are very interested in how education and research more broadly can apply what is available. And we would love to get your views on this, on how you see the opportunities for research and education to more broadly adapt available services.
Yes, there are different aspects where I see machine learning can really help the education field and research. And I would say that basically is we can kind of depict it as a journey, like what is the student journey, approaching the education system. And there is, for example, the possibility of helping students identifying what is the perfect matching with their aspiration and the courses available or the university. So initially, when a student goes and decide where to go, for example, in which university, which class to attend, here I see a very useful application of machine learning. So identifying what are the best available possibilities for the future of a student. Other things are, for example, once the student is enrolled, similar to the recommendation system again, what are the courses that he might want to follow, or even creating guardrails and understanding, okay, we need to pay more attention to the student because it might fall behind. So we have some telemetry basically about what he's doing in his university life and studies, so we can recommend some actions. So those are, for example, few examples. And we have, for example, the University of Portland the State University of Portland, that is applying those type of systems to understand what are the guardrails and which kind of support they can give to their students. When it comes to identifying which courses or which lessons are more useful for a particular students, we have example in the online learning landscape, where again you can suggest what to take or what is going next. And then of course there is the incredibly interesting research field, and there I would say the possibilities are endless, and we actually see it in practice. So a few weeks ago I was participating in a roundtable with some of our customers from Latin America. And two of those customers were basically trying to understand how they could help in this situation where we are, all of us, with COVID-19, right? So one of those customers is Clínica Las Condes in Chile. And what they are doing is using computer vision techniques to identifying problems or anomalies in X-ray images of chests, and so identifying, for example, potential indicators of COVID-19 issues. Another customer was actually Rumi.it, who is making robots that they are deploying, for example, in hospitals or airports. And again, one of the things that we learned in this situation is that we need to avoid contacts as much as possible. And so this robot has a conversational AI, so you can actually speak to the robot using Amazon Lex, understand what you're saying, and can give you indication of what you might want to do, or even take your temperature with a thermometer, remote thermometer. And so this is an interesting field on how machine learning is really helping, in this situation as well. And again, research is bigger than that, but one important thing is, again, going back to the concept of democratizing, is that, years ago, machine learning was something that only big research centers or big industries could afford. And the reason is because, as I said before, a lot of machine learning algorithms, they need data. They need big data to be trained. If we are talking about recognizing cat and dogs, we are, in around 10,000 or even more images that you need to process for having some meaningful results. And so a few years ago, that was only something big enterprises or big research centers could afford. But now with cloud computing, it's something that everybody can do. And so you can train yourself your own model. You can use GPUs at scale. So when it comes to the research, this is an advantage, because basically every university, every research center now have the ability to do the same type of researches that were only something big companies or centers could do a few years ago. So I think this one is a great advantage that we are bringing to science.
Maybe a question about that. I heard an interesting quote lately, which said, ICT problems are never really about ICT. So we have big access now to cloud computing and storage and GPUs and everything. But do you see, what are some of the problems you see with that? Could you comment on that? Or are there no problems? Or what's your vision on that?
Yeah, I don't really see problems. Is a matter of understanding how it works. It's probably more like probably an education. Allow me to use this word. It's probably like let people and let business owners understand how it works. Is a different environment, but we have successful story everywhere, in Europe, US, America, and Asia, everywhere, of governments or education using cloud computing. It's a different process, but everywhere they are realizing that is is definitely useful.
Oh yeah, so I was just thinking about so it's slightly different, the democratizing AI part. What's of course really nice, what you see right now is in AWS and services like it, like Azure and the Google Cloud Platform. You see these cognitive services and SageMaker and those kinds of applications, which make it easier to access AI and machine learning for lots of different people. But with it also, at least in the Netherlands, comes the worry that there's only a few of these platforms available right now. So there's basically 3 of these that are big enough. Do you see in the future that as part of the sort of democratizing effort of AI, that there will be more of these kinds of platforms, or will that happen somewhere else? Do you have an insight in that?
When you say platform, do you mean frameworks to use?
No, more like the compute platform. So, for example, if as an institute you would like to apply certain machine learning algorithms, you need to run them somewhere. So they might choose Azure, they might choose AWS. But the amount of these platforms is quite limited, and so the worry is once you've committed to one of these platforms and services, it's difficult to switch.
So first of all, I think competition is always good if can bring if you can help basically customers. So we really welcome that. I think that one thing I can't speak, of course, for Google on Azure, but what we are trying to do is to give options to our customers. So, for example, we don't pretend that we have a framework which is better than the others. Like, for example, is TensorFlow better than PyTorch or MXNet? So our philosophy is to really give options. So if a developer wants to use one framework because they are used to it, they can use it. And again, we are in a field which is very innovative. So we probably are going to see different frameworks, different applications, different tools coming up, in the next decade or in the next years quickly. So I think that the cool thing is to have a platform where you can really experiment and have ideas and try it, and then when you get value, then you decide what to do next. But again, the one thing that I really believe is a key differentiator that we have, for example, in Amazon Web Services, is this one. So the ability to have the customer using whatever options they want for their models, the type of technology and such. So not by default forcing them to use one thing.
Yeah. So if I understand you correctly, you expect the layer of services or like TensorFlow, PyTorch, those kinds of frameworks, that those will stay sort of agnostic of the platform on which they run. That's 2 separate parts of sort of the machine learning equation, the compute power and the frameworks themselves.
Yes.
Yeah. Right. Yeah, it was a quick intermezzo. I was just thinking about it. It's a worry, I know, at least amongst our members. But what I really like is that you see these frameworks. They seem relative to a lot of other ICT applications to be still very developed in an open source sort of format, right? I mean, as far as I know, at least most of them are shared. So that's good to see. Yeah.
Correct. Yes. If you mention, for example, MXNet is an Apache and it's an Apache project, and we are contributing a lot into the development. Again, we strongly believe that open source is important.
So you gave some nice examples earlier about recommendations and enrollments, helping students with their, being successful. I think what we've been trying to find out is what is a good starting point for an institution to get going. And as you know, but most of the listeners probably don't know, is that we've been working together, AWS and SURF, and we've been doing some workshops in this area, working with our member institutions. And one I particularly liked was the workshop where we experimented with the chatbots to see how this could be a nice way to get started with technology. What is your look on chatbots and their applicability?
So the first part of your question is how to get started, and I think you are doing, of course, the right approach. You're using the right approach, which is basically we need to remove the understanding, as I was saying before, that machine learning is something super complex. It is, behind the scenes there is a lot of theory, but the application is quite accessible. So doing workshops, try to take the courage to actually try and do something, with your hands dirty on the code is the right way to do. And so I welcome initiatives such as workshops for having a real idea of how to do those things. Conversational AI is very important. As I was saying, one of the goals that we see in AI ML is to reducing the barrier between interacting with processes and machine in general. So conversational AI is one of those. Think about if you want to interact with a sales department just to see if your invoice has been paid off. Right now, if you think about the process, is very manual. Most of the businesses, you need to call them and ask, hey, is my invoice being paid? I'm a supplier of you. And what they do is actually they go into the ERP application and they look for the invoice. They then reply. All those processes can be automatized very easily. And conversational AI bots are probably one of the easiest thing and a more effective way of doing it. So instead of calling, you just have a chat box with you, of course, with the all the layers of security that you need, that replies to you and say, hey, your invoice is due next week, so don't worry. And this is one example, in the sales, but we have hundreds of those in education. It might be the same. If I want to, for example, identify what are the opening hours of the offices in the university, I can just, for example, use a chat box. And so it's, again, simplifying and creating tools that basically make our lives easier. And especially in this situation where we are now, I think all of us appreciate those type of things. I can now quickly book an appointment with my doctor through those conversational AI, which is, for me, is amazing. Something that a few years ago we couldn't do it.
Looping back to the beginning, you said, or Anders asked, how did you get started? Were you dreaming of a career in AI? And you said, well, you started from a different perspective. So what advice would you like to give to a younger generation of people studying? Should they all become AI experts? Should they all become data scientists? Or is there another option? How do you see that?
Yeah, so somebody more important than me said be curious, right? So definitely curiosity and try to find something you are passionate about and try to solve it with machine learning. Again, we don't need to be all data scientists to use machine learning, and I'm one example. So have a passion, identify a problem that you want to solve, get your hands dirty, and start to learning those type of things. A friend of mine who is actually a machine learning practitioner, when I was starting this journey, he told me, Giulio, I really need to give you a secret. And, deep learning is very complex, but and there are a lot of algorithms that you might want to use. But there are only two algorithms that are very important in deep learning for you to use: deep copy and deep paste. And what he meant, it was fun. It was a joke, but what he meant is that for creating interesting application using AI ML, definitely you can reuse the algorithms that somebody else with more insights on the theory created, and then build on top of it. And for example, when you use Amazon SageMaker, you can reuse those models, and you can create a computer vision application without you being a computer vision expert. So you don't really need to know what a convolutional neural network is, but you can reuse the same architecture for actually making your cool application.
Good. Sorry, Duke. After you.
Oh yeah, no problem. Should a machine learning, like you said, a person that's getting in here, he or she is using deep copy and deep paste to make something new. Should those algorithms you develop be also preferably shared open source, so it's easier to deep copy and paste from each other as well?
So I would say that probably we need to thank you all in the academics, because most of the algorithms they come from the academics. So there are hundreds of papers that solve very, very challenging problems. So probably I would give back this question to you, and how probably it should be more accessible, the amount of papers or information about that from experts like you that are actually doing it for in the academics.
Yeah, so in that case, a call for open science as well on the on the machine learning algorithms. Easier to learn if it's accessible, for sure. Yeah.
In terms of making it more accessible, Giulio, where do you think the biggest obstacle is at the moment that prevents us from that breakthrough in a full-scale adoption?
I don't really see obstacles. I think again is probably what is holding is still the concept that you need a lot of theory and be a math guru for doing applications with machine learning. I think this is probably the biggest obstacle. I think we removed many of the obstacles now with cloud computing and all the interesting stuff that we are doing for enabling machine learning with the platforms such as AWS. So I think the undifferentiated heavy lifting, I would say, we are trying to remove it, and we are successful at it. So it's just now a matter of trying it.
And where do you think that level of proficiency should be? If, so to speak, for example, could one argue if you are proficient in using Excel, a spreadsheet, and do some formulas there, would that enable me to have enough skills to get going with ML tools? Or is it not that easy?
Well, definitely you need to. It's an interesting question. I think that, again, depends on the individual. There are some, skills also to develop macros, and having a level of proficiency in programming also in tools like Excel. And if somebody is curious, even if it doesn't have computer science background, what they can do is to enroll in the various courses that there are even online for machine learning. There are a few that are available in, for example, in online platforms such as Coursera. We recently released machine learning course there on AWS, or there are training options that we also have. So if somebody is interested in learning machine learning, I would say if they have zero programming language skills, probably they want to work on that first. But then I think is not that difficult to make the jump and use those more advanced tools. And again, there are plenty of online resources. We have a page, for example, in AWS training where you can see the trainings that we do have for machine learning as well.
Thanks, Giulio. And that brings me back to that very nice starting point that we had, that you referenced Star Trek. I always remember that quote from Star Trek, to boldly go where no man has gone before. I think that is something that you are already doing, which is great. I think it's very inspiring to us. And maybe to wrap things up, do you have for the listeners some other references or tips from any books or movies that you say, well, that is something to inspire you, to help you get started? I think you already mentioned the courses, etc. Is there something from popular culture that you think as a tip?
You mean apart from watching the entire seasons of Star Trek, all of
even the ones from the 60s,
the generations, of course. There are a number of books. One that I particularly like is The Art of Data Science, that kind of, for me, was enlightening on understanding how really you can do data science and think in processes, and how different it is, for example, from classical software development. That for me was a very nice, interesting reading. Something that also I can mention is have a look at the AWS machine learning blog that we have. There are a number of articles which are, basically they go from a very shallow level, I would say, in the sense that is easy to understand for everybody, to some more complex matters. But there is a variety that can give anyone an idea of what you can do with machine learning. So I was just opening the blog today, and I saw an interesting article about, again, sorry about, but it's still about cats, but it was, as you can imagine, I'm not only a Star Trek fan, but also a cat lover. But it was about how to identify if an animal is in a playful attitude. So in these articles, they were mentioning how you can recognize if a cat is in the mood of playing with you or with computer vision. So there are very interesting applications. Imagine how this can change the way we study animal behavior in the wild. But also some other interesting, more serious topics, such as, for example, how to use computer vision for identifying problems in the health, like cancers and something like that. So it's a very nice, interesting collection of information and articles.
Anything about cats is always welcome. So that one for sure. So we have the blogs, and we have The Art of Data Science by Roger Peng, I believe, is one of the authors on that book.
Yes.
So we will include the link for the listeners on our website. Giulio, thank you so much for this great conversation, where you've given us a great insight in your work and also some clear pointers and recommendations. So you were not only predicting today, but you only have given us some clear recommendations on how we can apply AI and ML, and that is tremendously useful to us. Thank you so much.
My pleasure.
Yeah, thank you very much. It was very interesting.
Thank you.